So here in 2.12, we are going to be graphing basic absolute value functions. So when we talk about absolute value, remember absolute value is these vertical lines here that always make whatever is inside positive. All right, so whether it's a absolute value of -3 or absolute value of +3, that value is still +3. So here I have kind of three different equations set up, and I'm going to go ahead and I'm going to edit these three in different ways, and you're going to see how what I do affects the graph. So in this red graph, we see this is just the absolute value of x. So for example, if I have the absolute value of 1, so for example, if I plug in a 1 for x, we would get out the letter, or the number 1, right? 1, 1 would be on this graph, right? If I plug in a 1 for x, the absolute value is 1, which is the y value. Likewise, if I plug in a -1 for x, then absolute value of -1 is +1. So we would get a +1 as well. So that is also going to be on the graph. Now we have this kind of turnaround point right at 0, 0. Now 0, 0 we call the vertex, all right? 0, 0 is called the vertex. And this vertex is going to change based on what numbers we have in this graph, all right? So when we graph these absolute value functions, we're going to be looking most often for the vertex, we're going to be looking for the domain, and we're going to be looking for the range. So hopefully you have headphones in or are listening to this out loud because I'm going to tell you what the domain and range are, and then you're going to need that information for the next questions on the Edpuzzle video. So my domain, notice how this red line, this graph, goes left forever and right forever. So my domain is going to be from -infinity to +infinity, all right, using interval notation. And then my range, well, the lowest value that we have is at 0, right? The lowest y value we have is at 0. Range is your y values up and down. The lowest value is at 0, and we go up to +infinity. So in interval notation, we'd use a bracket at the 0 because we're including 0. And then we would go up to +infinity and then close it with a parenthesis. All right, so that would be my domain and range. Now we're going to go ahead and see how adding numbers affects these graphs. So in my first red graph, I'm going to do x minus 2. And you can see, hopefully, that this graph has now been shifted 2 units to the right. 2 units to the right. If I take my second graph and I make it x minus 4, you can see that it has been shifted 4 units to the right. So it's actually kind of opposite of what you see. If I see x minus 2, it gets shifted 2 to the right. If I see x minus 4, it gets shifted 4 to the right. We might typically think it gets shifted left because of the negative, but that would be incorrect. It actually gets shifted right that many units. So if I type in x plus 3, you can go ahead and make a guess on your own, but if I type in x plus 3, we would guess that the graph should be shifted 3 units to the left. X plus 3, and if I show that graph, you can in fact see it gets shifted 3 units to the left, all right? So that is how the left and the right shifts work. Now what you'll also notice is that the vertex, if we put those vertices there, notice that in the red graph we have x minus 2. That means that the vertex has an x value of +2. In the blue graph we have x minus 4, so the vertex has an x value of +4. And in the green graph we have x plus 3, so the vertex has the x value of -3. So we can always see that the vertex, the x value, is located wherever, the opposite of what value we see the x value being shifted left and right, okay? So now what we're going to do is we're going to cover these up, and we're just going to go back to our original absolute value of x. This is called our parent function, by the way. Every single linear equation or absolute value equation, any of these quadratic functions, it applies to all these all have what are called parent functions that you learned back in Algebra 1. So these parent functions are the most basic value of this type of graph, and so y equals the absolute value of x is called a parent function here. So this is the most basic version. So now what we're going to do is we're going to do something after the absolute value. So I'm going to go ahead and I'm going to do a minus 2. And what you'll notice is that in this case, the y value gets shifted down 2 units. If I do x minus 4, we'll show this blue graph here, notice that gets shifted down 4 units. So in this case, when I have the plus or the minus, a number outside of the absolute value at the end, notice it gets shifted up or down that many units. Now, it's not opposite in this case like the x's were, right? When I shift left and right, the value that we see with the x is actually the opposite of the direction we shift it. Here, when we subtract a 2, for example, at the end, or we subtract a 4, it gets shifted down that many units. So that's actually the same shift. So for example, if I graph this green one and I do absolute value of x plus 3, if I do the plus 3 after, we should expect the green graph to be shifted up 3 units. So plus 3, and we do in fact see that gets shifted up 3 units. All right, so we can see all these vertices here. And again, what we should notice is that the number that comes after the absolute value, this actually tells us the y value of the vertex, right? So for my red graph, if I shift it down 2 units, the y value of the vertex is at -2. For the blue graph, if I shift it down 4 units, the y value of the vertex is at -4. And for the green graph, if I shift it up 3 plus 3, notice the y value of the graph is at +3. So what we can do here is let's go back and let's add some x and y shifts, all right? So for my red graph, I'm going to type in, and we're going to cover this up right now, I'm going to do x minus 3, and then afterwards I'm going to do a plus, let's do +5. So if we think about what we just learned, we should see that this graph is shifted 3 units to the right and 5 units down. 3 units to the right and 5 units down, and if we do this and we check, we can see that in fact it is shifted 3 units to the right and it shifted 5 units up, all right, just like we said. So if I x minus 3, absolute value, we get shifted 3 right, and we have a +5, so we get shifted up 5 as well, all right? So notice that the vertex is located at 3, 5. If we do another one of these, all right, we have absolute value of x, let's do +2 inside, and then outside we'll do a -4. So if we do this, we're going to notice that my vertex should be located at -2, +4. It should be the vertex, all right? So we're going to go ahead, and if we actually show this, we should in fact see that the vertex is at -2, +4. Sorry, it's -2, -4. So -2, -4, we look, we see the vertex, and that does check out. Now, if you ever don't have a value inside the absolute value, like we just have the absolute value of x, and let's say outside we have how about a +6? Now in my x case, we notice that the x value of the vertex should be 0 because it's not shifted left or right, and then the y value should be shifted up 6 units. So 0, 6 should be the value of the vertex, and if we show that graph, we do see that it is at 0, 6, all right? So that is how the graph gets shifted left and right, and that is how you identify the vertex of these. All right, let's go back and let's try this one more time because we can actually adjust one other thing here. So as I go and as I shift these values, let's delete these. All right, so one other thing we can change is we can change the value that's in front of this letter x. So again, this is my parent function. I'm going to keep this red one here, and I'm going to go ahead and I'm going to shift this function. I'm going to make it either wider or skinnier, all right, narrower or wider. So if I add like a 2, for example, or a 3, or a 4, or a 5, or a 6, right? Any number that is bigger than 1, this is going to make the graph even narrower, okay? So any number that you add in front of the absolute value, that will make your graph narrower than the parent function, than the red graph, as long as it's bigger than 1, okay? If I look at this green graph now, and I make this value, let's make this, how about 1/2, okay? Notice making it a fraction that's between 0 and 1, it's going to make the graph even wider than the red, right? I can make it a 1/3, I can make it a 1/7, I can make it a 1/10, right? All of these fractions that are between 0 and 1, this is going to make the graph even wider, okay? So again, with the blue, anything that is bigger than 1, right, like +1 or, like 1.5, 2, 2.5, 7.8, any number that's larger than 1 is going to get you a narrower graph like the blue. And then anything that is between 0 and 1, like 1/10, we could even do something like 3/10, right? 3/10 is still between 0 and 1, and that's going to make the graph wider, okay? Now the other thing, the last thing we can do is change whether this value is positive or negative. So for example, if I make this 6 absolute value of x into a negative 6, notice that what it does is it changes the direction of the graph. So it was pointed upwards, but now it is actually going to be pointed downwards. It makes these values all negative. Same thing with the 3/10. If I make this negative, it now flips across that x-axis and it is now pointing downwards. All right, so the other thing that we can realize is that if I make this negative, it is actually going to point downwards, not upwards, okay? So there's a few different things that we can do to these absolute value graphs, and that's going to change the results of this graph. So I wrote all this down here, all right? And what we do, we change this graph in 3 different ways, right? First thing we did was we went ahead and we changed the value of h, right? And so if I change the value of h, that's going to move the graph left and right. You can see I have a box around the h there. It says it's going to shift the graph left and right. And then the other thing we could do with k is we can see that k is going to shift the graph up and down. All right, k shifts the graph up and down. That's your y values. And then a is the number that is in front of the absolute value. All right, a is in front of the absolute value, and a is just a number. Okay, so if a is positive, my absolute value will open up. If a is negative, my absolute value graph would open downward. If a is greater than 1, now this also applies to negative, right? So like negative 6, we saw that opens downwards and it is skinnier. Positive 6 would also open upward and be skinnier as well. But if a is between 0 and 1, then it's going to be wider. We can also go ahead and take a look at just general ideas about the vertex, domain, and range, okay? The vertex is always located at h, k. So whatever the horizontal shift is, that's your h value. Whatever the vertical shift is, that's your k value. So the vertex is always going to be located at h, k. And then the domain is always going to be all real numbers, right? Because it goes left forever and it goes right forever. So domain is always from negative to positive infinity. And then your range is going to be one of these 2 scenarios, all right? If it opens downwards here, well, if it opens downwards, the highest value is going to be the k value, which is at your vertex. So it starts at negative infinity, and it goes up until you get to that value of k at the vertex. If it opens upwards, well, we see that the lowest value we could have is the value of k at the vertex, and the highest it will go is up to positive infinity. So this is always going to be kind of your general rule for the range. Domain is always the same here, and vertex is always the same here. So if we go ahead and try these 3 examples, we're going to try to identify the vertex, the domain, and the range for all of these. So if I look and I try to let's do the vertex first. All right, my vertex is going to be located at h, k. So if I look, I can see that my vertex is going to be at 3, 1. Remember that whatever we see for h, it's usually the opposite, right? Because of my formula is 8x minus h, so it's always the opposite of what we see. So it's going to be a positive 3, positive 1. All right. If we think about the value of a here, we see that a is 2. So this means this will be narrower than my parent function. All right, it's going to be skinnier, and it will also open up because it's positive. All right, so it opens up. And then we can think about the domain and the range. All right, my domain we know is always going to be from negative to positive infinity, all real numbers. And my range, we have to think about this now, right? If I think about what we just said about the graph, we know it opens up, and we know the vertex is at 3, 1. So we know that my range, the lowest value for the range is at 1, and it will go upwards forever to positive infinity. All right, let's try the next one. We have y equals negative absolute value of x plus 4. So if I think about my vertex is going to be located at h, k. So we see that we're going to have negative 4. There's no value after the absolute value, so that's just a 0 for the y. And then we can think about the value of a. Well, here a is equal to negative 1. So we know that this is going to be the same width, right? It's not going to be wider, not going to be narrower than my parent function. Whoops, y equals absolute value of x. And then we think about whether it opens up or down. Well, it is a negative 1, so it would open downwards. All right, and now we can go ahead and think about the domain and range. Well, we know that the domain is always all real numbers for absolute value graphs. And then the range, well, let's think about a little sketch of this graph first. So we know it opens downwards, and we know the vertex is at -4, 0. So the highest value we'll have is 0, and we're starting at -infinity, right? From -infinity up until 0, we will have y values, and we do want to put a bracket on the 0 because we are including that 0. All right, one last one here. See if you can pause the video right now and try this on your own. Try to identify the vertex, try to identify information about the value of a, and then think about the domain and the range. All right, so pause the video now and then resume once you think you figured it out. All right, so for my vertex, we see that we have a +0 with the x here. So there's really nothing with the x, so that's an x value of 0. And then we are shifted down 11 units, so -11 for the vertex. Then we're going to go ahead and think about this value of a. We see that it's going to be wider, right? 1/4 is between 0 and 1, so this will be wider than my parent function. All right, and then we know it's a negative, so it's going to open downwards. All right, and then we want to think about the domain and the range. Domain, we know, is the same for all of these, negative to positive infinity. And then the range, let's do a quick sketch. We know it opens downwards, it's going to be a wider graph. And the vertex was at 0, -11. So the range, the highest value we have is -11, and the lowest is -infinity. So we want to start with that -infinity, and then we make our way up to -11. All right, so that's just kind of the basic idea with these, how you would graph these, how you would find the vertex, whether it's wider, narrower, opens up, down, domain, range, all these things. So this information here, this is definitely stuff that you must know, okay? If you do not feel confident with this when you get to class, you need to take the time to memorize these things. If you want to go back to Desmos, Desmos is a great resource. You can go around and you can play around with it and ask yourself and quiz yourself and think about what the domain would be, what the range would be, what the vertex would be, and all of those kinds of things, all right? You can use Desmos to your advantage and just kind of play around with it and see how changing these values will shift the graph up and down and left and right and all that stuff, okay? So make sure you practice with this on Desmos. Make sure you know exactly what A, H, K do as well. And if you do all those things, you should be good to go for this section.